So in this problem, we are given an equilateral triangle with the coordinates of two of its vertices are provided to us. One is 0, 0 and the other is 3, square root of 3. We need to find out its third vertex. So let us begin. Now we'll start by considering a triangle ABC. So here we have A, B and C. Let us assume that B has the coordinate 0, 0 and C has the coordinate 3, square root of 3. And we'll suppose that the coordinate of A, let it be x, y. So our goal will be to find out the value of x and y such that will help us to obtain the coordinate of point A. Now, since it's given here that ABC is a equilateral triangle, so that would mean that the length of AB must be equals to BC, which is also equals to CA. So this is a known condition. Now, our next task will be to find out the length of AB, BC and CA by using the distance formula. So, the distance formula can be defined as, let's say, we have 2 points, point A having coordinate x1, y1, and we have another point B with coordinates x2, y2. So, if we join the 2 points A and B by using a straight line, then the distance of this straight line AB is going to be square root of, first we'll have to take the square of the difference of the x coordinate. So that's x2 minus x1 squared and add it to the square of the difference of the y coordinate, meaning y2 minus y1 squared. And this is going to give us the length of AB. So this is what we are going to apply, the distance formula. So let's begin by first finding out the length of AB. So AB, that's going to be equals to, so we'll have to take the square root. Now since we are considering AB, so we'll start from point B and from here we are going to subtract point A, meaning we're going to take the x coordinate of point B, so that's 0, and from it we are going to subtract the x coordinate of point A, so that's x. So we have 0 minus x whole square. Add it to, now we have to take the square of the difference of the y coordinate. Since it's AB, so we have to consider the y coordinate of point B first, and from it subtract the y coordinate of point A, so that's simply y. So we have 0 minus y squared. So this is going to give us square root of x squared plus y squared. So let's label this as number 2. Now we will try to figure out the value of BC. So BC is then going to be equals to square root of, so we'll have to do C minus B. So we'll do 3 minus 0. So we have 3 minus 0 squared and added to it will be square root of 3 minus 0 squared. This will be equals to 3 squared is 9. And square root of 3 squared, that's 3. 9 plus 3, that's going to be 12. So we have 2 times square root of 3. So let this be number 3. Now we will try to find out the value of length CA. So CA is going to be square root of, so we have CA, so we'll do A minus C, meaning we'll take the x coordinate of point A, so that's going to be x, and subtract from it the x coordinate of C, so that's x minus 3. We have x minus 3 whole square, added to it will be the difference of the y coordinate, so that's simply y minus square root of 3 whole square. So if we want, we can further simplify this. So we're going to get x squared plus y squared minus 6x minus 2 times square root of 3y, and added to it will be 12. So this is going to be number 4. Since the sides of the triangle are equal, we've already specified it, so we can say from 1, 2 and 3. So that means we're going to combine 2 and 3 by taking help of the relation as given in equation number 1, meaning we can say that AB will be equals to BC. So what's AB? That's square root of x squared plus y squared. So this is going to be equals to BC, so that's 2 times square root of 3. So if we square both sides, we get an equation x squared plus y squared equals to 12. So let this be equation number 5. Then we can use equation number 1, 3 and 4 to say that equation CA is definitely equals to BC. So that means we have square root of x squared plus y squared minus 6x minus 2 times square root of 3y plus 12, and this will be equals to BC. So BC is 2 times square root of 3. So if we square both sides, we're going to get the equation x squared plus y squared minus 6x minus 2 times square root of 3y plus 12. That will be equals to square of 2 times square root of 3 is simply 12. 12 and 12 will get cancelled out from both sides. So we have x squared plus y squared minus 6x minus 2 times square root of 3y equals to 0. So let this be equation number 6. Now what we can do, we can subtract 6 from equation number 5, or what we can do, we can substitute the value of x squared plus y squared with 12 in equation number 2. Either way, it's the same thing. So we are going to get negative 6x minus 2 times square root of 3y. So this will be equals to negative 12. Fine. Or simply we have 6x plus 2 times square root of 3y equals to 12. Dividing both each of the terms with 2. So we have 3x plus square root of 3y equals to 6. Fine. So this is going to be one equation which has only x and y. So let this be equation number 7. Now our goal will be to find out the value of x and y. So let's isolate y from equation number 7. So 7 will then become square root of 3 times y. So that's equals to 6 minus 3x. So y will be simply equals to 6 minus 3x divided by square root of 3. Fine. And what we'll do, we'll substitute this value back in 6. So back in equation number 5. So let this be equation number 8. So what we'll do, substitute 8 in 5. So we are going to get x squared plus y squared. Now what's y? That's 6 minus 3x divided by square root of 3 whole squared. So that will be equals to 12. Let's solve for x now. So we have x squared, added to it will be 6 minus 3x whole squared. So that's 36 minus 6 times 2 is 12. 12 times 3x is going to be 36x. Plus square of 3x, that gave us 9x squared. Whole divided by square root of 3 squared, that's simply 3. This will be equals to 12. Let's multiply throughout with 3. So we get 3x squared plus 36 minus 36x plus 9x squared equals to 12 times 3 will be 36. So we can cancel out 36 from both sides. 3x plus 9x squared, so that will be 12x squared minus 36x equals to 0. So we can take 12x as the common factor. So we have 12x multiplied to it will be x minus 12 times 3 is 36. So this is going to be equals to 0. And when we equate both sides, we get x equals to 0 or x equals to 3. So we have obtained two values of x. Now what we can do, we can substitute this value of x back in equation number 7 or back in equation number 8 to obtain the value of y. So let's use equation number 8. Here we have y equals to, so from equation number 8, let's write it down. Y equals to, so we obtain that this value is 6 minus 3x whole divided by square root of 3. So we'll use the value of x. So when x equals to, so when x is equals to 0, then y comes out to be 6 minus 3x. The 3 is simply, x is simply 0. So we have 3 times 0 divided by square root of 3. So we get 6 divided by square root of 3 and we get 2 times square root of 3. Fine. So that means one of the coordinate point is going to be 0, 2 times square root of 3. And for the other value, when we have x equals to 3, so this is going to be y equals to 6 minus 3 multiplied to 3 divided by square root of 3. So we have 6 minus 9 over square root of 3. We have negative 3 divided by square root of 3, which corresponds to negative square root of 3. So that means we have x equals to 3 corresponding to y equals to negative square root of 3. So that means 3 comma negative square root of 3. So this is going to be the other coordinate point. So that means the third vertex of the equilateral triangle, the third vertex of the equilateral triangle, so that will have two values. One could be 0, 2 times square root of 3. So this is one possibility, or we have other possibility which is 3, negative square root of 3. So let's go to our options. So we have one is 0, 2 square root of 3 and the other one is 3, negative square root of 3. So the options A and B are going to be correct.